Problems based on discrete random variables. Problem 1. A random variable x has the following probability distribution. X takes the values minus to minus 1s, 0, 1, 2, 3 and corresponding. P of x values 0.1 k, 0.2 k, 0.33 k. Find ik. EP of x2 and 3p of minus to x2. Solution. Find k. We know that summation p of x equals 1 implies 0.1 plus k plus 0.2 plus 2k plus 0.3 plus 3k equals 1. Add k terms and constant term implies that 6k plus 0.6 equals 1, therefore k equals 0.4 by 6, or 1 by 15. P of x less than 2 equals 1 minus p of x greater than or equal to 2 equals 1 minus of p of x equals to plus p of x3 equals 1 minus of 0.3 plus 3k equals 0.7 minus 3 by 15 equals 0.5. P of minus to less than x to equals p of x1 plus p of x equals 0 plus p of x equals 1 equals k plus 0.2 plus 2k equals 0.2 plus 3k equals 0.2 plus 3 by 15 equals 0.4. Problem 2. A random variable x has the following probability distribution. Value of x equals x is a 1, 2, 3, 4, 5, 6, 7. P of x is 0, a to a to a 3, a square to a square 7 a square plus a. Find i.e. p of x less than for 3 p of x greater than or equal to for I vp of x greater than or equal to 6 vp of x less than 6 $vi. If p of x less than or equal to k greater than 1 by 2, then find the value of kv. Find the CDF of x. Also find p of 1.5 less than x less than 4.5 given that x greater than 2, p of x less than 2, p of x greater than 3 and p of 1 less than x less than 5. Solution. IP of x greater than or equal to 0 for all x and summation p of x equals 1 implies 0 plus a plus to a plus to a plus 3a plus a square plus to a square plus 7a square plus a equals 1 implies 10a square plus 9a minus 1 equals 0 implies 10a minus 1 into a plus 1 equals 0, therefore equals 1 by 10 or equals minus 1, hence equals 1 by 10 since a greater than or equal to 0. EP of x less than for equals p of x equals 0 plus p of x equals 1 plus p of x equals 2 plus p of x equals 3 equals 0 plus 1 by 10 plus 2 by 10 plus 2 by 10 equals 5 by 10 or 1 by 2. EP of x greater than or equal to for equals 1 minus p of x less than 3 equals 1 minus 1 by 2 equals 1 by 2. IVP of x greater than or equal to 6p of x equals 6 plus p of x 7 equals to by 100 plus 17 by 100 equals 19 by 100. VP of x 6 equals 1 minus p x greater than or equal to 6 equals 1 minus 19 by 100 equals 81 by 100. VI to find the least value of k. P of x less than or equal to 1 equals 1 by 10. P of x less than or equal to t equals 3 by 10. P of x less than or equal to 3 equals 5 by 10 less than 1 by 2. P of x less than or equal to 4 equals 8 by 10 greater than 1 by 2. Therefore the least value of k equals 4. V to find the CDF of x. By definition f of x equals p of x less than or equal to x. Therefore the CDF of f of x is x takes the value 0, 1, 2, 3, 4, 5, 6, 7. F of x takes the value 0, 1 by 10, 3 by 10, 5 by 10, 8 by 10, 81 by 183 by 101. To find p of 1.5 x for 0.5 given that x greater than 2, p of 1.5 x for 0.5 given that x greater than 2 equals p of 1.5 less than x for 0.5 intersection of x greater than 2 divided by p of x2 equals p of x equals 3 plus p of x equals 4 divided by 1 minus p of x less than or equal to 2 equals 5 by 10 divided by 7 by 10 equals 5 by 7. P of x less than 2 equals 0 plus 1 by 10 1 by 10. P of x greater than 3 equals 1 minus p of x less than or equal to 3 equals 1 minus of 0 plus a plus 2a equals 1 by 2. P of 1 less than x5 equals 2a plus 2a plus 3a equals 7 by 10. Problem 3. The probability function of a random variable x is given by p of x equals 1 by 2 power x. X equals 1, 2, 3 etc. Find p of x is even, p of x is odd, 3p of x greater than or equal to 4 and p of x is a multiple of 3. Solution: p of x is even equals p of x equals 2 plus p of x equals 4 plus p of x equals 6 plus etc. equals 1 by 2 power 2 plus 1 by 2 power 4 plus 1 by 2 power 6 plus 1 by 2 power 8 etc. equals 1 by 2 power 2 into 1 plus 1 by 2 power 2 plus 1 by 2 power 4 plus etc. equals 1 by 2 power 2 into 1 minus 1 by 2 power 2 whole power minus 1 by 3. P of x is odd equals 1 minus p of x is even equals 1 minus 1 by 3 equals 2 by 3. 3p of x greater than or equal to 4 equals 1 minus p of x less than 4 equals 1 minus of p of x equals 1 plus p of x equals 2 plus p of x equals 3 equals 1 minus of 1 by 2 plus 1 by 2 power 2 plus 1 by 2 power 3 equals 1 minus 7 by 8 equals 1 by 8. P of x is a multiple of 3 equals 1 by 2 power 3 plus 1 by 2 power 6 plus 1 by 2 power 9 plus 1 by 2 power 11 plus etc. equals 1 by 2 power 3 into 1 plus 1 by 2 power 3 plus 1 by 2 power 3 whole square plus etc. equals 1 by 8 into 1 minus of 1 by 2 power 3 whole power minus 1 equals 1 by 7. Problem 4. A random variable x take values 1, 2, 3, for such that 2 into p of x equals 1 equals 3 into p of x equals 2 equals p of x equals 3 equals 5 into p of x equals 4. Find the probability distribution function and hence Find the CDF. Solution. Let into P of x equals 1 equals 3 into P of x equals 2 equals P of x equals 3 equals 5 into P of x equals 4 equals k. Therefore P of x1 equals k by 2, P of x equals 2 equals k by 3, P of x equals 3 equals k, P of x equals 4 equals k by 5. The probability distribution of x is given below. X takes values 1 to 3, 4. P of x takes values k by 2, k by 3, k by 5. We know that summation of P of x equals 1. Implies that k by 2 plus k by 3000 k by 5 equals 1 implies that k equals 30 by 61. X takes values 1 to 3, 4. Probability distribution takes values 15 by 61, 10 by 61, 30 by 61, 6 by 61. CDF takes values 15 by 61, 25 by 61, 55 by 61, 1. Problem 5. Let x be a random variable such that P of x equals -2 equals P of x equals -1 equals P of x equals 1, P of x equals 2, and P of x less than 0 equals P of x equals 0 equals P of x greater than 0. Determine the probability mass function of x and distribution function of x. Solution. Let P of x minus 2 equals P of x minus 1, P of x equals 1, P of x 2 equals a. Therefore P of x less than 0 equals P of x equals minus 2, P of x equals minus 1 equals a plus a equals to a. X takes values minus 2, minus 1, 0, 1, 2. P of x equals x takes values a to a. We know that summation P of x equals 1 implies a plus to a plus a equals 1 implies that k equals 1 by 6. X takes values minus 2, minus 1, 0, 1, 2. P of x equals x takes values 1 by 6, 1 by 6, 1 by 3, 1 by 6, 1 by 6. F of x takes values 1 by 6, 2 by 6, 4 by 6, 5 by 6, 1. Problems based on continuous, random variable. Problem 1. If the density function of a continuous, random variable x is given by f of x equals x, 0 less than or equal to x less than or equal to 1a, 1 less than or equal to x less than or equal to 2, 3a x, 2 less than or equal to x less than or equal to 3, 0. I find a. I find the CDF of x. Solution. I given f of x is the PDF of a continuous, random variable x, therefore integral minus infinity to infinity f of x dx equals 1. Implies integral 0 to 1 x dx plus integral 1 to 2a dx plus integral over 2 to 3a minus x dx equals 1. Implies a into x squared to by 2 limits from 0 to 1 plus a into x limits from 1 to 2 plus 3x minus ax squared by 2 limits from 2 to 3 equals 1. Implies a into 1 by 2 minus 0 plus a into 2 minus 1 plus 3a into a minus a into 9 by 2 minus 3a into 2 plus a into 4 by 2 equals 1. Implies a by 2 plus a by 2 equals 1 implies that a equals 1 by 2. To find the CDF of x, we know that f of x equals p of x less than or equal to x equals integral minus infinity to x f of x dx. Case I, if x less than 0, then f of x equals 0. Case E, if 0 less than or equal to x less than 1, then f of x equals integral 0 to x f of x dx. Implies f of x equals integral 0 to x by 2 dx dx equals 1 by 2 into x squared by 2 limits 0 to x equals x squared by 4. Case 3, if 1 less than or equal to x less than 2, then f of x equals integral 0 to 1 f of x dx plus integral 1 to x f of x dx. Implies f of x equals integral 0 to 1 x by 2 dx plus integral 1 to x dx equals 1 by 4 plus 1 by 2 into x minus 1. Case IV, if 2 less than or equal to x less than 3, then if x equals integral 0 to 1 f of x dx plus integral 1 to 2 f of x dx plus integral 2 to x f of x dx. Implies f of x equals integral 0 to 1 x by 2 dx plus integral 1 to 2 1 by 2 dx plus integral 0 to 2 x 1 by 2 into 3 minus x dx equals 1 by 4 into minus x squared plus 6x minus 5. Case V, if x greater than or equal to 3, then f of x equals 1. Problem 2. If x is a continuous, random variable whose PDF is given by f of x equals c into 4x minus to x squared, 0x to 0, otherwise. Find IC, EP of x greater than 1 solution. I given f of x is a PDF. Therefore f of x greater than or equal to 0 and integral minus infinity to infinity f of x dx equals 1. Implies integral 0 to 2c into 4x minus x squared dx equals 1 implies that c into 4x squared by 2 minus to x cubed by 3 limits 0 to 2 equals 1. Implies c into 2 into 4 minus 2 by 3 into 8 equals 1 implies that c equals 3 by 8. EP of x1 equals integral 1 to 2 f of x dx equals 3 by 8 integral 1 to 2 for x minus to x squared dx equals 3 by 8 into 4x squared to minus to x cubed by 3 equals 1 by 2. Problem 3. A random variable x has the PDF f of x equals to x, 0 x1, 0, elsewhere. Find IP of x less than 1 by 2, EP of 1 by 4 less than x 1 by 2, 3p of x greater than 3 by 4 given that 1 by 2 and IVP of x less than 3 by 4 given that x greater than 1 by 2. Solution: IP of x less than 1 by 2 equals integral minus infinity to 1 by 2 f of x dx equals integral 0 to 1 by 2 to x dx equals 2 into x squared by limit 0 to 1 by 2 equals 1 by 4. EP of 1 by 4 less than x 1 by 2 equals integral 1 by 4 to 1 by 2 f of x dx equals integral 1 by 4 to 1 by 2 to x dx equals 2 into x squared by 2 limits 1 by 4 to 1 by 2 equals 3 by 16. 3p of x greater than 3 by 4 given that 1 by 2 equals p of x greater than 3 by 4 intersection x greater than 1 by 2 divided by p of x greater than 1 by 2 equals p of x greater than 3 by 4 divided by p of x greater than 1 by 2 equals integral 3 by 4 to 1 to x dx divided by integral 1 by 2 to 1 to x dx equals 1 minus 9 by 16 divided by 1 minus 1 by 4 equals 7 by 12. IVP of x less than 3 by 4 given that x greater than 1 by 2 equals p of x less than 3 by 4 intersection x greater than 1 by 2 divided by p of x greater than 1 by 2 equals p of 1 by 2 less than x less than 3 by 4 divided by p of x greater than 1 by 2 equals integral 1 by 2 3 by 4 to x dx divided by integral 1 by 2 to 1 to x dx equals 9 by 16 minus 1 by 4 divided by 1 minus 1 by 4 5 by 12. Problem 4. Verify whether f of x is a PDF. F of x equals 1 divided by phi into 1 plus x square minus infinity less than x infinity. F of x equals modulus of x minus 1x less than 1, 0, otherwise. Solution. To prove integral minus infinity to infinity f of x dx equals 1 since f of x is a PDF, implies integral minus infinity to infinity 1 divided by phi into 1 plus x squared dx equals 1 implies that 1 by phi into tan inverse x limits minus infinity to infinity equals 1. Implies 1 by phi into phi by 2 plus phi by 2 equals 1, therefore given function is a PDF. Integral minus 1 to 1 f of x dx equals integral minus 1 to 0 minus x dx plus integral 0 to 1 x dx equals 1 by 2 plus 1 by 2 equals 1, therefore given function is a PDF. Problem 5. A continuous R dot and ohm variable x has a PDF f of x equals 6x into 1 minus x. 0 less than or equal to x less than or equal to 1. Determine b if p of x less than b equals p of x greater than b. BF solution. Given p of x less than b equals p of x greater than b, implies p of x less than b equals 1 minus p of x less than or equal to b implies that p of x b plus p of x less than or equal to b equals 1. Implies 2 into p of x less than b equals 1 implies that p of x less than b equals 1 by 2. Implies integral 0 to b f of x dx equals 1 by 2 implies integral 0 to be 6x into 1 minus x dx equals 1 by 2. Implies x squared by 2 minus x cubed by 3 limits 0 to b equals 1 by 2 implies that 3b cubed minus 2b cubed equals 1 by 2. Implies for b cubed a minus 6b squared plus 1 equals 0 implies that to be minus 1 into to be square minus to be minus 1 equals 0 implies that to be minus 1 equals 0 or to be square minus to be minus 1 equals 0. Implies b equals 1 by 2 or to be square minus to be minus 1 equals 0. Now to be square minus to be minus 1 implies that b equals 1 plus square root of 3 divided by 2 greater than 1, or 1 minus square root of 3 divided by 2, These values are not possible, therefore b equals 1 by 2. Problem 6. A continuous random variable x has a PDF f of x equals 3x squared. 0 less than or equal to x less than or equal to 1. Find a and b such that p of x less than or equal to a equals p of x a and p of x b equals 0.05. Solution. Given p of x less than or equal to equals p of x a equals 1 minus p of x less than or equal to a, implies 2 into p of x less than or equal to equals 1 implies that p of x less than or equal to equals 1 by 2, implies integral 0 to a f of x dx equals 1 by 2 implies that integral 0 to a 3x squared dx equals 1 by 2, implies x cubed limits 0 to a equals 1 by 2 implies that a equals 1 by 2 power 1 by 3, given p of xb equals 0.05 implies that p of xb equals 5 by 100. Implies integral b to 1 f of x dx equals 1 by 20 implies that integral b to 1 3x squared dx equals 1 by 20. Implies x cubed limits b to 1 equals 1 by 20 implies that 1b cubed equals 1 by 20, implies b equals 19 by 20 power 1 by 3.